I want to explain what focal length is, and because we ask you to set your camera or use the cameras, to shoot shots between a focal length of 45 and 55 millimeters for the unit, I want to just explain a little bit about that, because it is a bit confusing when you've got cameras with different sized sensors. So first I just want to credit some of the images I'm going to use. I've flicked through here and I've got a website from B&H called B&H website. There's also a really handy video here which you might want to come back and watch linked to on this website from B&H. The video is Understanding Crop Factor, or it's under that blog title. There's also another blog here called Photography Life, and I've used some of their images. So let's just go and start with one of these images and I'll try to explain this. So if you've got a full-size digital DSLR camera, or a DSLR camera at the professional end of the spectrum, will normally have a full-frame sensor. And a full-frame sensor is simply a fairly large sensor that looks like this on the left. In fact, it's approximately 36 millimeters long. Now, why is that called a full-frame sensor? Well, it's simply based on the old camera film format before digital cameras were around. We used to use film, and there was in most sort of normal cameras, you could say, not the large and medium format cameras, most normal cameras shot what we called 35 millimeter film, and it was literally 35 millimeters, across. These little sprocket holes are where the cogs would grab the film and you'd wind it through, and the little frames of the film strip would shunt in behind the lens, and then you'd click the shutter release, the light would come through the lens, hit the film strip, and an image would be captured. The shutter would close, or the aperture would close, and the film would be wound on, and then later on you'd go and process that film strip in chemicals, and you'd end up printing your images. So those old cameras, the film was about 35 millimeters across. Digital versions of those kind of film cameras, like a DSLR, uses a sensor with virtually the same size. So the Sony sensor on the left, full frame, is approximately, equivalent to the same area of that old 35 millimeter film strip. Okay, so that's one thing. Now, when a camera captures light through a lens, the amount of light that hits the back of the camera, you could say, is determined by the focal length of the lens. So focal length of the lens, you can kind of see it here in this image. Focal length is basically the distance from, I think it's the center of the front element or the main element where the light first enters the barrel of the lens, and the actual film or sensor of the camera itself. So that distance is the focal length. That's focal length, and that's fixed. So here's my 90 millimeter lens. So that's the center of the front element is actually in about there, and the distance between there and where the sensor is when it's mounted to the camera is 90 millimeters. So focal length is fixed. And if you look here, you can sort of imagine that the amount of area that any lens will throw onto the back of the camera is going to be the same. But what changes is the size of the sensor. So if in this diagram, you should be able to get a sense of it, the amount of light hits the back of the camera is the same, but if the camera's got a red sized sensor, a full frame sensor in this case, it's going to capture more of the image area. If it's got a green sensor, which is an APS-C size sensor, which has a crop factor of 1.5, I believe, then it's going to capture a smaller area. So in effect, it appears to be zoomed in a little bit. It appears to be a longer focal length. So the image on the right at the bottom, right, captured with the same camera, same lens with two different sensors. So hopefully that gives you a sense of it, and that's why we use the term crop factor, because crop factor is kind of the fraction of difference, the fraction that the sensor is in comparison with a full frame sensor. For example, here you can see a little diagram showing the sizes of different sensors. The one in the middle, where it's got on the left-hand side 1.00, that's what we call a crop factor of 1. In other words, that is a 35mm full frame sensor, or a DSLR size sensor. Most cameras, or a lot of cameras have that, but most of the point and shoot cameras, or even my little Fuji series cameras, the X100 series, these have a sensor that's smaller. It's about an APS-C size sensor approximately. And they have a crop factor of 1.5. And I'm not even sure if you could say it results in poor quality images. Let's not go there. Let's focus on the point here, Shane, which is that when the sensor size gets smaller, the crop factor changes. And if you've got a crop factor sensor on your camera, and you've got, let's say, a lens of a certain focal length mounted to the front, then to work out the normal field of view that camera lens would have seen, you have to multiply the focal length of the lens by the crop factor. For example, if this is a 50mm lens on the front of this Nikon and it had a full frame sensor, we'd see a field of view equivalent to a 50mm field of view on an old film camera. But if we put on the 50mm lens onto a APS-C size sensor, a smaller sensor with a crop factor of 1.5, then that same lens, a 50mm lens, will be cropped. The field of view is reduced, and it then becomes a field of view equivalent to, say, 75mm on a 35mm full frame sensor, or a 35mm equivalent is the term we use, or 35mm format. So that's it. All you do is you figure out the crop factor of your sensor, and it's going to be something like, it'll either be 1 if you've got a nice big honking DSLR, it'll be 1. You won't have to do any calculations. If you've got a smaller sensor, it'll be something like 1.5, 1.6, 2, maybe 5.6, depending on the camera. We've got a couple of students with a 5.6 crop factor. It's tricky, right? But most of the time, Flickr will tell you what's going on. So when this is Vicky's site here. When you go into Flickr, she's got a Nikon D3100. She's got a zoom lens of 18 to 55, right? So on her camera, it says this is a zoom of 18 to 55 focal length. And it is, that's the lens. But because this camera has a crop factor, I'll just close that for the moment. The Nikon D3100, let's just find that. This is a handy website, by the way. It's called Digital Camera Database, or DigiCamDB, and it tells you all the crop sensor sizes, crop factor sizes of your sensors. Sorry, so she's got a 1.56 crop factor. You can see it here. So a 1.56 crop factor on Vicky's camera means that if see here it says 48mm. 48mm times 1.56, let's get the calculator out, is 74.9. Now, let's see what this says. If you go inside Show EXIF in Flickr, and then scroll down to focal length. Now, there's so much data here, it can be hard to find. So what I sometimes do is do Command F, type in focal, and there it is. So she's got, here the EXIF data tells us it's 72mm equivalent, right? My calculator said 74.8, so it's, something's different here. A margin of a few millimeters is not a problem. So basically it's saying is 48mm on her camera is actually shooting a field of view of about 72mm if that was on an old, well, it's equivalent to a field of view of what we're equivalent to the field of view captured by a lens on a full frame camera. This is so hard to explain. Okay, so that's that. So let's try another one. Hayden. Now Hayden's got a tiny little sensor on his Fujifilm FinePix. It's a 5.6 crop factor. It's one of these ones right down here, this tiny little green one. He's a miniature little sensor. So on that one, he's got to actually multiply it by 5.6. So here it says 18 mil. 18 mil times 5 is about 100. So in fact, that photo was taken at an equivalent of about 100mm lens. But it gets really complex in Hayden's case because for whatever reason, we can't see the equivalent focal length of the 35mm format camera here. It's only showing us other information. So Hayden had to do a couple of test shots and just kind of, and then we had to just sit down and say, okay, look, that's, when it's showing 9.1, that's about a 50mm. So approximately 50mm field of view is on his camera 9.1mm, right? So it's confusing, but all you need to do is multiply the focal length of the lens by the crop factor. So 9.1 times 5.6 is about 48, 50 mils, and that's the field of view that we want you to shoot at. Beck here, okay, she's shooting with a D5300 Nikon 18 to 55mm lens. So her focal length on a, because I think this is a crop factor of 2. Let me just check that. Focal is 48, so it's showing a 48 equivalent. So therefore, it's a 1.5 crop factor. So 32.7 times 1.5 equals 49. Yeah. So she's got a 1.5 crop factor, and you can again find that out by looking it up. So, well, that's it, everyone. Went over time. Hopefully I've made some sense. Please maybe review this or go back and watch the video from the B&H website that I mentioned earlier, Understanding Crop Factor, and the video down the bottom of that blog is called Crop Factor. So let me know if you've got any more questions. Otherwise, all the best, and hope this is expanding your brain just a wee bit. It certainly did mine.